chemical shift in C13 NMR. You're interested in the x-axis. Where peaks show up along this x-axis tells you what the carbons you're interested in are bound to. There are two magic numbers in carbon NMR. There is 0.0, and that is TMS, tetramethylsilane. This is what we put into our NMR solvent to serve as a reference point. Right at 0 is where that shows up. And 77.16 is specifically CdCl3. The presence of the deuterium causes the carbon NMR signal to split into 3. But other than that, all other signals in the carbon NMR will be single line. Unlike proton NMR, carbon NMR only consists of single line. The interesting ranges in carbon NMR, essentially down in this 10 to maybe 30 range, are things like methyl groups at the end of a chain, or other boring stuff. Generally between 10 and 30, alkyl chain sort of thing. Between generally 50 and maybe 80 or so, 90, somewhere in there, that's when you have an oxygen. So you'll have a carbon that's bound directly to an oxygen or nitrogen or chlorine, fluorine, something like that. The more electronegative the group that is bound to the carbon, the further left you tend to be. The more electropositive the group, but still somewhat electronegative, like a nitrogen or maybe a sulfur, the further right you are. So for example, a chlorine will tend to show up further left than maybe a bromine. Another region of interest in C13 spectra is the double bond range. Here there's no distinction between double bonds in rings like benzene and isolated double bonds. Carbon-carbon double bonds show up in the range between 100 to 150. Right around 175, you see interesting carbonyl behavior. Specifically, it'll be a carbonyl that has an oxygen also bound, so carboxylic acids and esters show up at 175. Ketones or aldehydes are also going to show up in the carbonyl range, but they will show up closer to 200. Broadly speaking, there are 4 regions of interest. There's the boring stuff between 10 and 30. There's the bound to electronegative stuff between, say, 50 and 80. There's the double bond stuff between 100 and 150. And then there's carbon-oxygen double bonds, either in the 175 with 2 oxygens bound flavor, or 200 single carbonyl presence bound to just carbons or hydrogens. So that's chemical shift for C13 spectra.